Hi everyone, so this is just a little project update video. So in regards to the motor controller I'm developing, that's stalled just now because I can't get parts for it. There's certain very important parts that are just not in stock anywhere. So the design is completed and it is just ready to go, but it's just those parts that are stopping me. So at least I'm making progress with it. Anyway, this here is the BMW range extender inverter, which I did a partial disassembly of in another video I made, I think about 2 years ago. But I've decided to go and take the thing apart completely because I actually want to make a VESC based board to control it. So it can be maybe used in some sort of development project or small electric vehicle project in the future. This is the original motherboard. To get it to power on is actually quite simple. This motherboard is useless anyway because there's just no way I'm going to figure out how to control this. And it'll probably only work with a certain motor anyway. As I just soldered a wire between these two connections here, that's actually 12 volt and wake up. And then what I'll do is I'll just put a clip on ground and then run my power supply in. Just clip onto this pin in the corner here, and the board would power up fully. And I was able to just like measure voltages where the supply voltage is coming in, and I've also been looking at data sheets to reverse engineer this, and I've got most of the way through reverse engineering this. I've got the gate driver pinouts to map to this connector. I've got the current sensing mapped on. The only issue I'm struggling with now is I've no idea how the heck this thing is sensing temperature or phase and DC voltage. I just haven't got a clue. So I think what I would probably do is, if we look at it here, the only way to get this power stage apart, by the way, was to I had to pretty much destroy it. It can be soldered back together, that's not a problem. But I actually had to cut through this plastic, because this is actually a single-use connector. The whole thing is held together with these horrible single-use connectors, where you have to actually use snips to snip the tops off them so you can pull boards apart. And then once you press them back together, you can just put solder in there and solder them back together. And these were just a giant version of that, so I had to actually cut them open. And this silver thing, I had no idea what the heck it's made out of, but my grinder couldn't even cut through it. It's just like the clip, the one-way clip. So that when this was assembled in the factory, everyone was just pressed and clipped together. I don't really, well, it must work anyway, the engineers obviously know. But these are the IGBT modules, so these are half-bridge IGBT modules, but there's no information whatsoever about this. I've no idea what it's capable of, power output, nothing. As originally used on the range extender in the BMW i3, and that thing could output, I think, about 35 kilowatts maximum, but that was running the motor as a generator, so I don't know what its motoring power actually is. I've just had a figure in my head all the time that it would probably handle 60 kilowatts, no problem, with good cooling. But this is the whole thing here, the whole power stage anyway, just this massive capacitor. It's not an electrolytic, I think it's a massive film capacitor, 420 microfarads. And as you can see, there's my design up there. I'm just trying to figure out the pinout of the IGBT module itself. So if you just imagine it sitting like that, it's just a half bridge. That's just connected to battery positive. You've got battery negative there, and imagine those are the gates, the two gates for the high side and low side there. I did have a theory that maybe temperature sensing was done by way of a sensor inside these, but I'm getting ever more doubtful of that. possibly there's temperature sensor to ground and maybe temperature sensor positive, or I don't know. I'm going to do more investigation into that, but I reckon if I was to make a Vesk board, I would just make something roughly this shape. Chances are I don't even know what kind of connector this is here, so how on earth I'm going to get these to people I don't know, because this is another project idea that I want to make drop-in boards for various inverters, but it's not really going to be drop-in if you have to solder over voltage sensing wires from the board to the IGBT modules and stuff. So I want everything just to be on the one board, and the user doesn't have to do any soldering at all. But this connector, that would just get pulled off in the Vesk based board, and it would just be sort of some 3D printed stub just with 2 big cable glands coming out of it, and just like a selection of wires like you get on a bike controller, because I have no idea what connector this is, maybe amp seal or something, I'm not sure. But that's the project I'm working on just now. And another problem is I probably won't even be able to get parts for this until next year. I'll be looking at the stock and it's just not good, but I'm just going to do what I can just now.